All right, this is the review for the statistics unit for Algebra 2. Starting with question number 1, part A, what type of function would best fit the graph? So if we look at that scatter plot, the general shape that it makes is going to be a quadratic function, so that would be B. For the second part, I know it says part C, but if a linear function is used to model, the relationship, which residual would you expect? Well, if we go back and we look at this, if we use a linear model, that's a line, so it would look something like that, and we decided that the residual plot is going to follow the same kind of pattern that we see if we were able to rotate this. So if we look at that linear function or that linear regression compared to the graph, and we compare it to the two residuals, it looks like residual B, and that's because since a linear function is a bad fit, there is a pattern to the residuals. Okay? Question number 2. In the table, X represents the number of hours you've worked. So we have a table, construct a scatter plot of the values. So we're just going to plot all those points: 110, 215, 325, 430, 535, 640, 750, and 870. And then part B says draw a line of best fit for the points. And what I actually did is I used the calculator and had it draw the linear regression for me, which looks something like that. Okay. This is based on the relationship, predict the amount of tips you'll receive if you work 5 hours. Well, according to this, we would receive about $40. So then part D, what type of correlation, if any, is there between hours worked and money and tips you've earned? So we can see that that is going to be a strong positive correlation. Something that I forgot to do, that we'll go back and do now, is we need to label the graph. The x-axis is, if we look back, it's hours worked. And the y-axis is tips. All right, question 3. What is the equation of line of best fit you created in the scatter plot in problem 2b? So we used our calculator to do all that. I'm not going to go over on here how to use the calculator again. We can work on that in class. But we just do the, make the table in the calculator, do the linear regression, and we should get y is equal to 7.68 x minus 0.18. All right, number 4. Tara created a budget for her weekly expenses. The graph shows the amount of money. We can see all that stuff here. Find the slope of the line. We'll remember that slope is y2 minus y1. It's going to be 2,000 minus 2,400 over x2 minus x1. That leaves me with, in the calculator, I get negative 50. The meaning of that slope, so that's rise over run, so that's the amount of money we make per week. So it means she loses $50 per week. What's the y-intercept? Looking at the graph, it looks like it's $2,600. What is the meaning of the y-intercept? It's the amount that Tara started with. All right, number 5, you find a line of fit for a data set and calculate the correlation coefficient is 0.78. Select all that apply, so it's a positive number, so it's positive correlation. And because it's 0.78, we said that anything about 0.75 or higher was going to be strong, so it's a strong correlation, and it's also a good fit for the data. Number 6, We have a table, hours of studying, exam score, calculate the correlation coefficient. Again, I'm not going to show this here, but we would use the calculator to do it. And we get 0.88. And what does that tell you? It tells me that there's a strong positive correlation between hours of study and exam score. Number 7, which statement below might be caused? So that's a keyword, caused. Remember, cause means there's a direct cause and effect relationship. The more it rains, the less time individuals spend outside. That's usually true, but it doesn't cause you to not be outside more. Some people have to be outside in the rain. The more it rains, the straighter her hair is. Not always true. The more it rains, the colder it is. And D, the fuller the outdoor pool becomes. D is the only possible answer that's actual cause and effect, because the more it rains, the more the pool fills up. Number 8, which statement might be correlation? So correlation is just, is there a connection between the two, whether it's directly or indirectly? So if we look at this, the more your air conditioner runs, the more customers at Big Surf. Probably true. The higher the temperature, I think it depends on what that means as far as temperature. Does it mean the higher the temperature outside or the higher the temperature inside? If we say it's the higher the outside temperature, that's also true. The cheaper the ice cream is at the store, probably not. The more kids go swimming, probably when it's, the more you run your air conditioner, it's probably summertime. And the more expensive ice cream is, maybe. And the more kids go skiing, definitely not. So I would say for sure those 3, maybe even more expensive. It's the summertime, they could probably charge more for ice cream because of demand. Number 9, we have a table showing the homelessness rate and the crime rate. Ignore the height of the bouncing ball. That was just a typo. Someone didn't copy it correctly. But we need to find the correlation coefficient. It is 0.998. And there is a correlation because of that, because that's a really strong number. Is there a cause and effect between the percentage of homeless people and the crime rate? I remember cause and effect is direct relationship between the two. And I would say no. There is no cause effect because the correlation could be due to other factors in this case. So homelessness does not cause crime, which is basically what we're thinking about here. Okay? And that is going to do it for the regression part of the review. There will be another video coming up for the measures of center, mean, median, mode, box plots, histograms, things like that.